Up next on Science Goes to the Movies, Lewis Black and Brian Greene are going to answer the universal math question, when am I ever going to use this in my life? Welcome to Science Goes to the Movies, a look at the stories of science and how they change our culture. I'm Faith Saley, and today we have Professor Brian Greene and comedian Lewis Black here on set to talk about math jokes. Welcome.
Thank you.
I'm so happy to have you both. In 2013, Simon Singh of The Guardian wrote, "Without doubt, the most mathematically sophisticated television show in the history of primetime broadcasting is The Simpsons." And why wouldn't it be when 5 of the comedy writers from The Simpsons have degrees in math or physics from Harvard University? And you probably think the image you're looking at on your screen right now is those very writers posing with their high school math team, but that is in fact our guest Brian Greene in his 1977 Stuyvesant High School math team yearbook photo. But it doesn't matter because all math team yearbook pictures have and will forever look exactly the same from now until eternity. Yes?
I agree.
All right, now Lewis, I want to warn you, these chairs don't have seat belts, so buckle up because we're going to hit some really hard math puns. You ready?
Oh yeah, puns, my favorite.
All right. I want to remind everyone that since 2009, when it surpassed Gunsmoke, The Simpsons is the longest-running American primetime TV series. That said, in the finale of season 26, called Mathlete's Feet, there was a math joke hidden in a frame that looked like this. And the answer was, it was delicious. Our guest, Brian Greene, is a professor of mathematics at Columbia University, but it turns out Mr. Black over here has got a few math chops as well, calculus and everything. So I'm going to ask Lewis Black to start on this first. Professor Lou, take it away.
Well, as everyone knows, Faith, the square root of -1 is an imaginary number, as we know everybody. I mean, and seriously, everybody.
Ask anyone on the street.
Exactly. Which is noted by the symbol I. So this joke starts out saying I.
I, right,
I.
Okay. I, yes. Here. All right, now I'm going to throw in my 700 math SAT score from 50 years ago and tell you that the second piece of it is 2 to the 3rd power, which is 2 times 2 times 2, which is 8. So now we have I8, and Professor Greene, I will let you take it on home for us and explain what happens next.
Man, it feels like explaining a joke. It's stepping on it, but here we go. So sigma, Greek symbol, means sum, add things together. In this case, S-U-M, sum. And as those thousands of people certainly know, the last symbol is pi. So if you put it all together, perhaps we say it together.
Okay. I ate some pie. And it was delicious.
There you go.
Lewis, are you laughing deep down inside?
Oh yeah. Yeah, that's. I'm seriously not laughing at all. And anybody out there who is laughing, please take a deep breath and try to find some comedy somewhere in your life.
Wait, Brian, had we not sit down to dissect this, and you, with your professor of mathematics mind, just breezed by the equation with all those symbols, would it have immediately made sense to you as the setup of a joke?
I would have taken a moment and I would have smiled deep down inside somewhere.
All right.
Just above your pancreas.
Yeah.
All right. Let's get a little bit deeper. On The Simpsons, like most cartoon characters, almost everyone has only 4 digits on each hand. However, 2 characters, and only 2, in the Simpsons universe have all 5 fingers. Okay, so if either of you can tell me why having only 4 fingers would mess up a character's, mathematics, then I will tell you which 2 characters got to have 5 fingers on each hand.
Well, it wouldn't necessarily
No, raise your
mess it
hand,
up.
please.
I'm sorry, I'll take this one.
Please
Just I'll do it first, yeah.
Please.
It wouldn't actually mess things up. It would change them from the base 10 that we're used to, where 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, to base 8. And actually, there are some things in the world where it's easier to think in base 8 than base 10, so it could have been an improvement.
Is music base 8?
Well, anything in which you need to divide things in half. Base 8 is much more natural because when you go from column to column to column in base 8, you're going by factors of 8, which itself is just factors of 2, which means if you want to divide through by 8, you can do that easily by just doing 3 divisions by 2, and we know how to divide things in half. It would have been more intuitive. In fact, it is a tragedy that we have 5 fingers on each hand and not 4.
Wait, is this the...
And in fact, I'll go a little further.
Hold on, this seems like you're in high school debate team all of a sudden.
I'm sorry,
that you're arguing
you
for base 8.
showed me in high school, and it's like bringing it all up to me.
Right, but do you, wait, hitherto, before this moment, did you really always think it was a tragedy that we're not a base 8 society, my friend?
Maybe that was a little bit of hyperbole I got tossed in here. But actually, there are civilization societies in which they don't count by the fingers, they count by the spaces between the fingers, and there are 4 of those.
Yes.
And they naturally come to base 8 just like we would have in this Simpsons reference.
Can you give me an example of such a society?
Oh, geez, you can look it up, no doubt. Lewis knows the answer to
the
this.
Mayans.
I don't think the Mayans.
It was the Mayans.
I think the Mayans are base 20. If you check this
Seriously?
out. Yeah, I'm pretty sure.
How many
Well,
webs
that's what
did
it
they
said
have?
in the thing. It said
Oh, I'm
Mayans.
sorry if it says in the thing.
You
then
know,
it's
if it
true.
says in the thing, that's what I'm relying on. I have to go with the thing.
Yeah, then you're right. Then you're right.
The teleprompter tops the mathematics
Yeah,
professor.
I'm pretty sure mine was base 20, but I could be wrong.
But, you know, if we had a book and we could look in the back of the book
Or
for
if
the
we had
answer.
Siri. Can we just bring this out?
Alexis, what kind of society had base 20?
Yeah.
All right. So very good. You get an A for that answer. Oh, yes.
You know what's interesting, though? You may know this. I've read this a while back about the Chinese in terms of their math, that they do it. You know, that they are base 10, but but in terms of their language, it's like that the language is such that it's easier for them to add quickly rather than us.
I see. Yeah, well, I can certainly imagine.
You know?
I mean, look, adding is not natural, right? It's something that you have to acquire.
Yeah.
And if the language allows you to acquire it more efficiently, that's better.
You'll end up with 25,000 emails about this because I don't have the precise answer. I do know that 6 plus 7 equals 13. Okay,
True.
but that's 6 plus 7 equals 13, which is what you mean in terms of complication. In part, but the Chinese have it to a point where it's like it's basically 10 plus 3. So it's already inherent in the language that the answer is there.
All right. Well,
Don't ask me how. Write in, send letters, dude. Please show some love.
all right. So everyone breathlessly wanting to know the answer to this question. So to whom on The Simpsons did the creators give 10 digits and therefore a natural understanding of base 10 decimal calculations? Do you know?
No, of course not. I don't. Who pays that much attention to their hands?
It's a fascinating answer. Only God and Jesus, who have appeared on The Simpsons.
Wow.
Which means, I guess, according to the writers, decimal calculations are a gift of the gods in a way.
Or, according to every elementary school kid, they have to memorize a multiplication table that's about 56% larger than if it were in base 8. So I don't know how much of a gift every kid will view this as.
Interesting.
Wow. I'm glad you weren't my math teacher. It could have been brutal.
All right.
Base 8, you bastard. Base 8.
Let's try this one. By the way, in class, were you always the class clown, even as a kid?
I was the one who knew. I wouldn't call it class clown. There were people I hung out with who I thought were much funnier than me, but what I knew to do was when it got too serious in a room, I knew when to pull the string. I knew when to pop a joke. When to kind of, okay, enough's enough. Let's get out of this funk and move into. It's basically, and it really isn't being the class clown. It's just giving energy to the room.
All right. So this next one is from Futurama, season 1, episode 11, called Mars University. This diagram is called Whittons Dog, and it has something to do with super-duper symmetric string theory, and also my producer informs me that this is a poop joke. Okay, so Brian, who is this Whitton person, and does he really have a neutrino pooping dog?
Well, Edward Whitton at the Institute for Advanced Study is widely viewed as the successor to Albert Einstein. I mean, he's probably the smartest person on the planet.
He's alive.
He's alive. Yeah,
Have
very
you met
much
him?
alive. I've worked with him. I've sat in the office with him as we all get very quiet as we watch him think, and we don't want to disturb whatever thought process is happening.
Where is he at? Where's he?
Institute for Advanced Studies, so in Princeton, New Jersey.
Wow.
Yeah.
So you really, you're like one of the smartest people I've ever met, and you go and sit with Professor Whitten and just watch him think?
Yeah, just so it's clear, if like most of us are here, Ed is up here. I mean, there's no...
How? How do you know? How do you know?
Because I've watched him look at problems that I had no insight into, and he just, in the privacy of his own brain, solves it and works it out. It's amazing.
Wow. Can he work with the federal government maybe for an hour? There's some math problem.
Yeah.
So what is going, when you look at this image, is that real math there? And is there really something that's, well, probably not super duper. Is there super?
Well, there's a thing called superstring theory, and that diagram is a scattering amplitude of strings that are coming together in terms of the whole neutrino quality of this. I mean, neutrinos are these little tiny chargeless particles. About 1 trillion of them just pass through your body and yours and mine as well. They're all around us, so it's not surprising that perhaps you'd have a neutrino in this diagram.
What is neutrino?
It's an elementary constituent of the world that surprisingly has tiny wispy mass, has no electric charge, which means it can pass through trillions of miles of matter without being scattered. It just passes through it as if it's not there.
So atoms, molecules, and now it's...
Well, neutrinos are not part of that sequence.
They're not?
Because they are a constituent of reality that doesn't participate in making atoms that make up you and I, but yet they are produced by interactions like things that happen in the sun. The sun is spewing out a bath of neutrinos, and those are the neutrinos that are passing through us all the time.
So we all do, in fact, pass neutrinos. I mean, it is universal poop in a way, right?
Yeah, I'll let you say that. But yeah.
Happy to say it. I have no dignity. So the Simpsons and Futurama are kind of like math kids passing notes to each other from across the world in these kind of jokes, yeah?
Little inside jokes, yeah, that's what it is.
And they can do that because an equation is like a sentence. Is that right?
Yes, a well-formulated mathematical sentence. That's what these symbols mean.
Yeah, but if I have a sentence and I screw up a verb tense in the sentence, it makes some sense. You can follow it. Those who've been watching me talk now have a sense of my never getting certainly things right. But you make one little mistake in an equation, and the bastards throw the whole thing out. Now, why can't math recognize minor errors and just get on with it?
Well, because we have formulated this language to speak about the world with utter precision. So the flexibility that you're talking about, that's what allows us to speak in flowery terms and emotional terms about life in the world using ordinary English. But when it comes to mathematical sentences, there's meant to be no interpretation. There's meant to be a specific and precise meaning so that we can get on with the job of figuring out what these equations are telling us. And it's that inflexibility that you're responding to. It feels unnatural, but it's powerful.
So there is nothing that is the equivalent of like an adverb or an adjective in math? No,
there is, but it's not open to interpretation. So if two mathematicians or physicists look at a mathematical sentence, they both interpret it in exactly the same way. Whereas, if I take an English sentence, you two may see colors of interpretation based on your own state of mind or your own history. We want to eliminate that human side that allows us to talk about the world in an objective, precise way. That's what the language of mathematics is all about.
Well, what's interesting about that is the language also, because we all speak, you know, the way in which you inflect on a word changes it too. You can't inflect on, you know, x to the third power or whatever.
X to the third power.
No, I liked math in school, but but in the end, who cares really why the train that's leaving from Albany traveling at light speed goes for 5 seconds and then explodes? I mean, what I don't understand is that there is something that I was really good at math.
Yeah.
I mean, really good, and could do all sorts of these calculations. And I had no idea why I was doing them, none whatsoever. And yet I know from the way I hear you talk about it, and I've heard other folks who've dealt with math talk about that, and you know, when I watch a TED talk,
Right.
you know, they kind of, there is something magical that's happening in there, and for some reason, you know, teachers from time immemorial have not been able to get that across. It's just kind of like, give me the answer.
Yeah.
No one explained to you how it applied to your life,
Not
even
at
though you
all.
were great at it.
Yeah.
Yeah, but what you're pointing out is the tragedy of education, because within these mathematical sentences are deep truths about reality, and it's a powerful language to master, because you can then make predictions about what happens in the world. I mean, think about what it would have been like 1,000 years ago to sit down with a piece of papyrus or whatever and be able to scratch out a calculation that predicts the next solar eclipse. And then it actually happens. That's power. So if a teacher can communicate to a kid like you the power of the insight that comes from understanding this language, it changes the way you interact with these ideas. And when I hear stories like that, I feel pain. I swear, I feel pain.
Well, no, because it's amazing, because it is like, you kind of get, okay, somebody hands you Shakespeare, somebody hands you a novel, somebody hands you, you know, a movie, you kind of, there's stuff going on. The same thing is happening in math, the precise same thing. And for some reason, it has always been difficult for that expression to get through to folks. And it is, I agree with you, tragic, because it's...
Yep.
It's not delivered with the excitement and magic that Brian is delivering
Yeah.
now. And it was never explained to me, and I took calculus too. I couldn't even remember, I can't even tell you what it means now, and I did well. But it was never explained to me as, this is a language.
Right, well, the reason is we so quickly focus in on the details because those are the things that we can test. We're such an assessment-oriented educational system, whereas if we would just luxuriate in the beauty of the ideas for part of the time, we would recognize more broadly that, yes, Shakespeare speaks about life. We all know that intrinsically, right? But math speaks about life too. It just is a different language and opens up the world in different ways. And that's what's missing.
And yet, in the way that you describe math, math is the great communicator, because no matter what language you speak, everybody agrees on what it says. And it's saying one thing to everybody.
That's right, there's no translation.
What I always found stunning about when I finished high school, when I was somewhere in college, and really just toward the end, when I got my first tax form, is why, in the name of God, that the one thing that math applies to in our daily lives, besides measuring and whatever, but the major thing it applies to is taxes.
Yeah.
And that they don't, not once that I know of in the history of no one I know who went to school was okay, now let's apply this practically to this idiotic form that you've been given, and that you have to fill in the blanks of it. And what do these things mean? Yeah. And it's just extraordinary to me that that's ignored.
Right. You know, from taxes to black holes and the origin of the universe, right? And it's a language that can really cross the whole domain. And the fact that most of us don't have that experience, that's the tragedy.
Yeah. Now, I'm going to ask you a deep and serious question kids have been pondering for generations. And when, besides taxes, am I ever going to use this stuff in my life?
It depends, you know. Look, my mom has no idea why I do what I do, right? She still wishes that I had become a doctor.
But that's
right?
Yeah, but that's
You know,
universal. And
yeah,
that's universal, and maybe universal Jewish.
It's universal Jewish.
You guys have the same mom?
Yeah, that's right. You know.
Oh yeah, no, they're all connected.
So not everyone's going to use math or even find any of this exciting.
But wait, not
yeah.
everyone's going to use math?
Not in a way that goes beyond taxes, let's say. You know, I think in everyday life, of course, you have to encounter the usual symbols that describe the quantitative things that we encounter. But that's not math. That's arithmetic. Math is insight into the way the universe works. And that is the side of mathematics that not everybody's going to experience, and that's sad.
Is that a Brian Greene? Did you just coin a Brian Greene saying right there? Is that
no? I think if you talk to most of my colleagues, well, look, the mathematicians go even further. They say reality, mathematics is its own reality. There are patterns that we're able to ascertain that go beyond anything that's realized in terms of chairs and tables. And that to them is an even bigger reality. I'm very modest. I'm just saying the reality that we encounter can be described mathematically, and that's deep and powerful.
Yeah, I'll give you an example of that. Is my father, who was a mechanical engineer and plays video poker, right? And not unlike but like nickel. I mean, just appalling video poker. Well, but doesn't gamble on, the way you should. It's like, if there are two kings, et cetera, you're supposed to keep the. He does it all on what he thinks the series are going to be. All of it's based on what he thinks that reality is.
As opposed to probabilities.
Right, exactly.
Right.
He goes to the world that the math people that you're talking about go to.
Right.
That this is what's going to happen in the series. And I've watched him play, and I go,
how's he doing? Is he up?
Every so often, he's never up, but he was playing a nickel, so it doesn't even matter.
Sure.
But we could be playing with matchsticks, that maniac. But what's amazing is that he'll do something, and I'll go, no, boom, it hits. And he goes, see, I told you. It's like,
Brian,
but it's based on that whole idea of probability.
Do you think that understanding math the way that you do changes the way you live in this world? I mean, what is it like to, on a daily basis, what is it like to live with such a quantitative understanding?
Well, I think all of us, live in the real world in more or less the same way. But I would say something that echoes what Richard Feynman, great physicist, once said. He says, look, when I look at a flower, right, some would think that my understanding of physics spoils the experience, that I've taken away the mystery of it. He says, no. When I look at the flower, I can see the red and I can smell the wonderful aroma, but then I can penetrate more deeply. And using mathematics, I can understand how the molecules and atoms combine and yield the color and yield the aroma and where it all came from. So it's a deeper experience of the rose, not a diminished one.
Where do the neutrinos go?
They're there all the time.
Can't you smell them? They're all over the place. That reminds me, wasn't it an Einstein quotation where he said, like, either everything's a miracle or nothing's a miracle? That his understanding of science made everything miraculous.
That's right. And I totally agree with that. Every time I've studied Einstein's work for 35 years, if not longer. And yet every time I look at it, I find it breathtaking because it's so unexpected yet so rich. That time doesn't elapse as you think, that space isn't what you think it would be, that there's a potential origin to the universe, that we can use equations to describe the expansion of space. It's breathtaking.
Our conversation with Lewis Black and Brian Greene just kept getting better and better as it went on, but our show is only about 26 minutes long, and so we decided in editing to share the second half of the conversation with you in the next episode of Science Goes to the Movies. In that next episode, Brian Greene and Lewis Black discuss how and when and why math became political. It's an interesting exchange of ideas that we're happy to share with you next time on Science Goes to the Movies. Until then, check out our Science Goes to the Movies Facebook page for web-only clips and to keep up with everything related to Science Goes to the Movies all in one place. And if you want to watch past episodes, check us out at www.CUNY.TV under the Science tab. Or try out our new YouTube channel where you'll find lots of science and lots of movies.